Vamos a continuar.
Fine, let's continue to look at the beauty and the science of things. Our next speaker is an expert in physics. His name is Joaquin Sevilla, PhD in applied physics in the Autónoma University in Madrid. He's a professor at the University of Navarra, and he's also responsible for the chair on dissemination of science. Joaquin is a physicist of the small things.
Buenas tardes.
Good evening. I'm here to explain a tiny little thing, which is how to sleep well on any planet. And to extrapolate this to any planet, let's start by analyzing what does it mean to sleep well on this planet. As Javier said, I'm a physicist. I'm going to talk about sleeping well from the physical viewpoint, right? You need to have a clean conscience and all those things that are fine, they're very important, but I'm not going to talk about that here. Right. If you see a situation on someone sleeping well, almost every time they will be laying down, right, practically in a horizontal position. If you look at other situations where there are people sleeping, you see that, well, probably these people, when they wake up, they're going to be stretching their muscles and they're going to feel uncomfortable if they've been sleeping for a while. If it was just a nap, that's fine. But if you had to spend a night in a hospital, together or next to someone who is ill, or you had to sleep on a train, or this type of situation, if you sleep a whole night in a position that's not horizontal, then it will make you feel, uncomfortable. You don't sleep very well, actually. And this is because there are different stages to our sleep, and in some of them, well, sleep is a biological complex and very complex process that has a number of different stages to it, and in some of those stages, in order for us to sleep deeply, both in a deep sleep and in REM sleep, our muscles need to be completely relaxed, because there's no muscle tone at all. Because we need to be able to sleep, and so that our brain cortex needs to work as if we were alive or living in actual reality, but without any action, without any movement at all. So we don't have any signals going through our neck, etc., etc. So in that situation, our muscles are completely relaxed. So for the muscle to lose all their tone, so that we don't fall, so we can maintain our posture, we need to be in a horizontal position, right? On a bed, for instance, normally, right? That's where we sleep well. But what is this horizontal position we need? Because this is what I want to extrapolate to different planets, right? If you think about it, our homes are full of horizontal and vertical things. And if you think about that, what's interesting about the horizontal elements is what I just told you about. I mean, we need for them to compensate for gravity at each point, and the vertical elements would do the opposite, right? Horizontal and vertical element. Well, the horizontal surfaces are the ones that have the same potential, the equipotential surface of a gravitational field, right? Maybe you haven't thought about this before, but this is very relevant for almost everything except for designing a bed on a different planet where this gravitational field is not the same as the one we have on our planet. But there's a little detail we need to take into consideration here. If you think about how a shelf would look like on a small planet, for instance, the one of Little Prince, which is the one I found in the literature, well, the Little Prince in his trips goes to very small planets like this one. If that planet existed, and if we could live there, and if there was enough gravity there, the shelves, vertically would have specific angles, and horizontally would have different angles, and this would correspond to the equipotential surface, and the bed would be curved. if he was to sleep well, like us on our planet. But this is fiction, of course. The Little Prince is fiction, and you never know how he sleeps, right? But if he had to sleep like us, that would be what his bed would look like. But there's one more detail we need to take into consideration. We need to be in a horizontal position, more or less, like these peasants by Van Gogh. We need to be in a soft surface, right? Our beds are soft and horizontal. And in physical terms, what does this mean? It means that taking our weight into consideration, well, our weight will generate a concave surface so that we are in a stable position, right? We have this equipotential surface of a gravitational field, and we also need slight curve so that our balance is stable. So if I slightly move, if there's a movement or something that makes me move, that curve remains or brings me back to my position. Unlike other types of balance that we see here, right, and which are not desirable for us to sleep well. If we slept in that position, we wouldn't be sleeping well, clearly. Right, so something that seemed that relevant, that our question was, what is it? What does it mean to sleep well from a physical viewpoint? Well, it means two things. We need an equipotential surface of a gravitational field in the first approximation, and the second thing we need is to have this curve that provides a stable balance. So we need these two elements, right? We know what we need to be able to sleep well in physical terms, right? That's something we do every day. Now let's try and extrapolate this to another planet, to any other planet. And if we had to design a bed or a shelf for this Churyumov-Gerasimenko comet, which is the one that years ago, where we sent a probe years ago, that was supposed to land there, but it didn't work very well. So depending on where our bed or our shelf would be, depending on the area, we would have a different structure. We, of course, need to analyze the gravitational field of this comet, right? If the mass is homogeneous, then the surface, the equipotential surfaces will have the same shape. But you never know. We may have a higher density or lower density depending on the area. Fortunately, the bodies that have shapes that are not spheres or spherical, or in other words, in the bodies where gravity is important, it's very hard to have an equipotential surface, and it's very hard for them not to be spherical because gravity helps to create that shape. So if we were to sleep in a place like this one, like this asteroid, or on a similar one, a small object where gravity is very irrelevant, as in the International Space Station, then the problem would be different. I mean, we don't have the problem of gravity because we don't have much gravity there. Our problem, well, we would be in a bubble, which is what they have on the ISS. And the problem would be that since there is no gravity, there's no convection. I mean, hot air weighs the same as cold air. So you breathe. When you breathe, you're still. The air you expel stays there. And the one that you're going to breathe in is the same air. And maybe a few meters away, there is oxygen available, but you're going to breathe as if you were breathing in a plastic bag. So you need to have a fan there to create an air draft. And when you're awake, this would not be a problem because you're going to be moving and you would make the air move. But in the deep sleep stages, you need that fan. So if you're in a place with no gravity, with a very low gravity, then you need a fan. And if you're going to sleep in a place where gravity is greater, then you need a bed or a surface that is equipotential of a gravitational field, and you need a stable balance. Thank you very much for your attention.
Bueno, la NASA o Elon.
Well, NASA, Elon Musk, I don't know who will be first, but someone's going to ring him, right?